Welcome to The Explainer. Today, we're decoding a bit of a mystery, one that's literally hiding in plain sight. We're talking about the invisible, completely essential tech that silently powers our entire modern world. So, I want you to think about this for a second. What connects a drone soaring through the sky, the microwave heating up your lunch, and the car sitting out in your driveway? From the literal second you wake up, you interact with these wildly different machines. But what do they actually have in common? Well, the answer is they all contain tiny, invisible computers. And no, I'm not talking about the kind of computer you keep on your desk. Actually, scratch that. They aren't like your laptop or your smartphone at all. These are highly specialized, microscopic brains built to perform just one specific task, but with absolutely incredible speed, reliability, and efficiency. Okay, let's dive right in. Today, we're going to cover the invisible computers everywhere, what they are, a peek inside their tiny brains, how they work, the different types, and finally, where this is all heading in the future. All right, section 1, the invisible computers that are everywhere, every day. You know, it is so easy to take for granted just how much hidden tech we rely on without ever even noticing it. Just think about your standard morning routine. Your alarm clock rings, your coffee machine brews that perfect cup, you turn on your smart TV, take the elevator down to the lobby, and hop in your car. Boom! Every single one of these actions is completely powered by an embedded system. The sheer volume of these hidden devices operating seamlessly in the background of our lives is honestly staggering. Moving on to section 2. What exactly is an embedded system? It's all about the art of specialization. Think of a general-purpose computer, like your laptop. It handles multiple tasks, runs a massive operating system, and is super flexible. Now compare that to an embedded system, like the one hiding inside your washing machine. It has one dedicated task, uses a tiny little piece of firmware, and is hyper-optimized for that one specific job. It doesn't let you browse the internet, and let's be real, your washing machine definitely doesn't need to play video games. But because it's so wonderfully specialized, it operates faster, cheaper, and with way more energy efficiency than a standard computer ever could. So, if we boil it down, the crucial takeaway here is this. An embedded system is a specialized computer designed to perform one or maybe a limited number of specific functions inside a larger device. Think of it as the dedicated brain of a machine. It's continuously monitoring inputs, processing information, and controlling outputs all in real time. It's not a jack of all trades. It's meticulously optimized to hit the nail on the head for one exact job. Which brings us to section 3, inside the tiny brains. Let's look at the actual hardware. Every single part of this setup plays a highly specific role. First up, you have the processor, usually a microcontroller that acts as the brain calling the shots. Then you've got memory. You have flash memory for storing the program, RAM for temporary data, and EEPROM memory. And honestly, that EEPROM is the magic ingredient that lets a device like your washing machine remember your favorite custom wash cycle even if the power goes out. Pretty neat, right? Next, we have input devices, sensors or buttons gathering data from the real world. And finally, output devices, like a motor spinning or an LED screen lighting up. It's this beautifully simple, self-contained little ecosystem all living on a single board. All right, section 4, how they work. The continuous loop. Let's walk through how this actually plays out in real time. It is a continuous loop. Step 1, a sensor collects data. Maybe it's measuring temperature or motion. Step 2, the processor instantly receives that data. Step 3, the software analyzes it. Step 4, the processor makes a split-second decision based on that analysis. And Step 5, the output device responds. A motor spins, a buzzer goes off, whatever it might be. Now here's the crazy part. This entire 5-step cycle repeats itself hundreds, thousands, or even millions of times every single second. This insane processing speed is what makes modern machines feel practically alive. Let's jump to section 5. Types and applications. How do we categorize all this tech? So we can actually take this exact same processing loop and group it into 4 distinct types across completely different industries. First, standalone systems. Think of your microwave. It just does its job completely independently without needing a host computer. Second, real-time systems. These are absolutely critical, like the anti-lock braking system in your car, where a millisecond delay is quite literally not an option. Third, networked systems, like your smart home router, constantly chatting with the outside world. And finally, mobile systems, like the complex flight controller inside a drone, doing the crazy math of balancing gyroscopes and motors mid-air. Now, to really put the sheer scale of this into perspective, just think about this number, over 100. A single modern car rolling off the assembly line today contains more than 100 independent embedded systems, all working together. You don't just have one big computer in there. You have dozens of separate, tiny computers independently controlling the engine, the brakes, the airbags, the navigation. You're essentially driving a massive, rolling network of over 100 specialized brains.
And that leads us perfectly into Section 6, the future, AI and beyond.
So, where is all this invisible technology heading next? Well, the landscape is rapidly evolving, and the biggest game changer by far is artificial intelligence. Historically, AI required these massive, power-hungry cloud servers. But now, we're seeing the rise of things like TinyML and Edge AI. Basically, artificial intelligence is migrating from the cloud directly onto these tiny local devices. Because of this, robots and smart factories can become completely autonomous. They process their own data instantly without having to wait for a network connection. Cars are learning to drive themselves using complex embedded sensor networks, and medical devices are getting smart enough to analyze your vitals right on the spot. The convergence of AI and embedded electronics is fundamentally reshaping our entire physical world. We've definitely covered a lot of ground in this explainer today, decoding the invisible hardware and software powering our lives. But I want to leave you with a provocative thought to chew on. What embedded device do you use every single day without even thinking about it? Seriously, take a second and look around your room, your kitchen, your workspace. Once you start noticing these tiny, highly specialized computers, you realize just how surrounded we are by this brilliant technology. Thanks so much for joining me today. Keep exploring the hidden tech around you, and I'll catch you in the next explainer.